Exercise and neuroplasticity are closely related. Neuroplasticity is the brain's ability to reorganize itself by forming new neural connections throughout life. This adaptability allows the brain to recover from injuries, learn new skills, and adapt to new situations. When you repeat an activity or exercise, you strengthen the neural pathways associated with that action. Over time, this leads to more efficient processing, which is why tasks become easier and feel more automatic. This phenomenon is part of neuroplasticity and is often referred to as muscle memory, though it involves the brain as much as the muscles. Repeatedly performing an action can also enhance memory retention. This process, known as consolidation, helps embed the learned information or skill into long-term memory. The more you practice a task, the stronger and more durable the neural connections become, making it easier to recall the information or perform the skill even after a long period. Moreover, regular physical exercise, especially aerobic exercise, has been shown to support neuroplasticity by promoting the growth of new neurons, neurogenesis, and enhancing synaptic plasticity. This can improve cognitive functions such as memory, attention, and learning. The phrase, neurons that fire together wire together, is a fundamental principle of neuroplasticity, often attributed to the work of Canadian psychologist Donald Hebb. This concept helps explain how learning and memory formation occur in the brain. In practical terms, if you practice playing the piano, for example, the neurons responsible for the specific finger movements, timing, and coordination required for playing will fire together. With continued practice, the synapses between these neurons become stronger, leading to smoother, more fluid playing. Essentially, the brain is rewiring itself to perform the task more efficiently. When you repeatedly perform an action or practice a skill, specific groups of neurons, nerve cells in the brain, are activated together. Each time these neurons fire simultaneously, the connections, synapses, between them become stronger. This process is known as synaptic plasticity. Over time, as these neural connections are reinforced, the brain becomes more efficient at performing the task, and the action becomes more automatic. This principle also relates to memory. As the same neural circuits are activated repeatedly, the connections become more robust, making it easier to recall the skill or information later. This is why repetition is so effective for learning and why habits are so hard to break. The neural pathways have become well established through repeated use. So, in summary, repeated practice of an activity not only makes it easier to perform, but also helps strengthen and sustain the memory of that activity over time, thanks to neuroplasticity.